In this video, we're going to define rigid motion and we're going to use a congruent statement to determine congruent sides or angles. So remember that congruent means that there exists a composition of basic rigid motions. Remember, think back a couple of chapters. We have translations, we have a reflection, or we have a rotation that maps on one figure onto another. So this is shown with the triangles because they have exactly the same size and shape. So triangle ABC is congruent to XYZ because everything that's in the same letter placement is congruent. So A is congruent to X, they have the same measure. B and Y are congruent because they're the second letters, and C and Z are congruent because they're the third letters. The same thing works for sides. So AB is the first two letters. That's congruent to XY, which is the first two letters in the other triangle. BC is congruent to YZ, and AC is congruent to XZ. So as you can see, the location matters. So since we're saying that ABC maps onto XYZ, we are saying that the following vertices and segments match up. So if we have angle A, the angle that matches up with angle A would be angle X because they're the first letter in the name. B matches up with Y because they're the second letter of the names. And then C would match up with Z. The same thing is true again about the sides then. So if I have side AB, AB is the first two letters, so that's going to match up with the sides XY. So XY. BC is the last two letters, so that matches up with YZ. And then we have the other letters, which are AC, which is the first and last letter, matches up with X and Y. So C is first, and we're going to say Z and then X. So remember that the order is important when we're trying to say that things are congruent. They have to go in the same order. So the angles that match up are called congruent angles or corresponding angles. And the sides that match up are called corresponding sides. So if two figures are congruent, then all pairs of corresponding sides and corresponding angles are congruent. So let's use that idea to complete the statements in number 1 and 2. So number 1, we have triangle NIU and triangle HDJ. So notice that the triangle for HDJ is turned, so we need to pay attention to the letter placement in the names. So angle N is the first letter. So angle N matches up with the first letter of the other triangle, which would be angle H. Angle D is the second letter in the second triangle, so that's going to match up with angle I in the first triangle. Then if we look at sides, so in our sides we have side IU. So IU is the last two letters, which then would match up with DJ. Our other side that we are given is JH. So J and H are the first and last letter, so that would match up with UN. So number 2 is without a triangle. So if you need to draw a triangle to help you, you can, or you can just go based off of the names. So angle A is the first letter, so that's going to match up with angle T. Angle W is the first letter, so that matches up with H. When I look at my sides, I have LA, which is the third and second letter. And that's going to match up with the third and second letter again, so BT. And our last side, we have WB, which matches up with HL. Now, in the last one, it's saying triangle. It changed the triangle name. So the triangles are the same, but it gave us a different order. So when I name my second triangle, I need to know what letter matched up with L in the original triangle. So we have B, H matched up with W, and then A matched up with T. So we're just changing the order so that the letters match up with the corresponding angles and sides. So number 3, pause the video and try marking all the congruent sides and segments. So looking at number 3, T matches up with N, I matches up with E, and M matches up with W, and then you're going to mark the congruent sides and congruent angles. Make sure if they're congruent, they have the same type of marking. So given the triangles, let's complete the congruent statement. So in the first one, we have triangle KMI, and we need to match it up to get our second triangle. So the first letter K, look at angle K. Angle K has 2 congruency marks, so we need to see what angle in the other triangle also has 2 congruency marks, which would be G. So G is the first letter. The second letter is M, which has 1 marking in the angle. A has 1 marking in the other angle. And then I is a right angle and R is a right angle. So they match up together. So we would have triangle KMI is congruent to triangle GAR. In our bow tie problem, we have triangle KAE. And we need to figure out what triangle it's congruent to. So triangle, so K has 1 congruency mark. So we need to follow where the 1 congruency mark is, and that would be L. Now, just because B is at the top with K doesn't mean that they are congruent. You need to pay attention to the congruency mark, because in a bow tie problem, it's actually flipping the angles from top to bottom to be congruent. So we have triangle L, and then we have A because A is the shared letter, and then we have B because they both have 2 congruency marks. So now we're going to use congruent triangles to solve for a variable. So in number 5, we have triangle GRA, and we have triangle PES. So they gave us that GR is 2x plus 3, RA is 4y plus 2, GA is 2x plus y, PE is 15. Oops, sorry, PE is 15. ES is 6y minus 8, and PS is z. So first I want to look and see what sides match up. So I know that 2x plus 3 matches up with the side that's 15 because they're both the first 2 letters in the name of the triangle. So to solve for x, we'd have 2x plus 3 is equal to 15. So we're going to subtract 3 from both sides. 2x equals 12, and divide by 2, so x equals 6. Next, we can look at side RA, which is the second and third letter. So RA matches up with ES, which is also the second and third letter. So 4x plus 2 is equal to 6y minus 8. We can subtract 4y from both sides, so 2 equals 2y minus 8. Add 8 to both sides, 10 equals 2y. So when I divide, I get y is 5. And then lastly, we have 2x plus y equals z, but we already know what x and y are, so we can substitute those in. So 2 times 6 plus 5 equals z. So we get 12 plus 5 equals z, which means that z is 17. In number 6, solve for x and y, find the measure of angle E. So I need to pay attention to the names of the triangle. So H is the first letter, so H matches up with K, which is the first letter in the other triangle. O matches up with E because they're the middle letters. And then angle C matches up with angle Y. So to solve for x, I'm going to use the h and the k, so 2x equals 64. When we solve, we get x equals 32. For y, c and y are congruent, so y plus 12 equals 2y minus 28. So I'm going to subtract y from both sides and add 28 to both sides, and I get y equals 40. Now, once I know y is 40, I need to know what this angle actually is to help me get angle E. So 2 times 40 minus 28. Well, 2 times 40 is 80. 80 minus 28 would get us 52 degrees. So to get the measure then of angle E, remember that a triangle has 180 degrees. So we're going to subtract the two angles we know, 64 and 52. So when I subtract those angles, I get that E is 64 degrees. Now, thinking back to rigid motion, remember that rigid motion is an action of taking an object and moving it to a different location without altering its size or shape. So remember that a translation moves an object remember that a reflection flips an object, and that a rotation turns an object. So which rigid motion transformation would make the given triangles congruent? So in number 7, they're the same triangles, just in different spots. So that means we picked it up and moved it somewhere else, so this would be a translation. In B, we have two triangles, and they're sharing the same point. So remember, when they're sharing the same point and they're slid in a different spot, facing a different direction, this is a rotation. Number 9 are two triangles. They have a shared side, which means that they were reflected over one side. So this would be a reflection. Number 10 actually has two movements because we have a translation because we moved it from one spot to another. And it's now facing a different direction. So we also have a rotation. Number 11, describe the transformation needed to map ABC to A prime, B prime, C prime. Perform each transformation separately on the figure. So the first thing we can do is we got to move this triangle somewhere over here a little bit more so it's better closer to our triangle. So we're going to say that we are going to translate all points of triangle ABC. And since we don't have a coordinate, we're just going to say what directions. So we're going to say to the right and up. So point B overlaps. So when I do that, I have my triangle here now with B, A, and C. Next, I'm going to rotate triangle ABC so that the tip of C is at the bottom. So I'm going to rotate 90 degrees clockwise, about point B, because I don't want point B to move. So when I do that, B stays put. Now I have A and C. And then my last transformation is I need to get it overlapping. So I'm going to say reflect triangle AB over the line or over the segment BC so that it flips onto the other triangle. What do we know about these triangles? So looking at the picture, what do we know about the triangles? We know that the triangles are congruent because, as we have talked about, the rigid motion doesn't change the size and shape. So we would say that they are congruent because rigid motion preserves congruency.